Unit 1, Understanding Liebig's Law of the Minimum. So Justus von Liebig was a chemist, and he sort of jumped from chemistry to agricultural chemistry. He was around or alive from 1803 to 1873, and he did quite a bit of work that we nowadays take for granted. He solidified the role of atmospheric derived plant mass. What does that mean? He was, if not the first, one of the first to define and realize that carbon necessary for plant growth did not come from soils, did not come from the degradation of organic matter, that it came from carbon dioxide from the atmosphere. And if you're ever really interested in learning about this a little bit more, I encourage you to go dig into the literature, Google this, and find out how he actually did this. It's really fascinating. He also identified the importance of soil minerals for plants, that a large majority of minerals came from the soil. And so there's a combination here between the atmosphere and the soil for growing plants. And Justus von Liebig was the foundational person for identifying these roles. He was also the first to show that inorganic nitrogen fertilizers or inorganic nitrogen acted as a fertilizer. So he could take urea or uric acid and apply it and see a crop grow or a plant grow to a greater extent than if it did not receive that nitrogen source. And thus he's been coined the father of agricultural chemistry. And his law of the minimum, Liebig's law of the minimum, specifically states this: by the deficiency or absence of one necessary constituent, all the others being present, the soil is rendered barren for all those crops to the life of which that one constituent is indispensable. Now that's extreme. I mean, that is an extreme statement. And I can tell you that this is almost never true. And thus, a better way of stating this is that crop yield is proportional to the amount of the most limiting nutrient, right? So soils typically contain almost every single macro and micronutrient necessary for plant growth. It's typically never zero in terms of concentration. But we have deficiencies in our soils which limit crop growth, okay? And this is illustrated, Liebig's law of the minimum is illustrated with this barrel and these different tines within the barrel, which are these pieces of wood, okay? These are called tines. And in this case, these are all different nutrients, and the most limiting is nitrogen. So the lowest tine in the barrel is where the water leaks out, or in the cases of plants, the most deficient nutrient in terms of plant growth. Now, you can add fertilizers, you can add nitrogen fertilizers specifically and raise this tine. And then the second most limiting might be phosphorus. And the third most limiting in this case might be either calcium or potassium. And this is how this works. And this is why when we study soil fertility, we keep this concept in the back of our mind to understand what the most limiting is, or several limiting nutrients in terms of plant growth, and try to overcome them with the use of fertilizers or amendments.